And thank you again, Dr. Lim Kiang Wee, for inviting me to present today's keynote. Now, over the years, Singapore has established its position as a living lab of urban innovations and research to shape the city of tomorrow. It is my pleasure to share with you Singapore's experience in leveraging science and technology for sustainability, the need for an integrative framework for a science of sustainable cities, and to discuss the key enablers towards this goal. In cities, people, urban systems, environmental factors influence one another in emergent and unpredictable ways. As the eminent complexity scientist, Professor Jeffrey West had said, we cannot make our cities work better until we know how they work. In Singapore, Chairman URA, Mr. Peter Ho, in his recent World City Summit keynote address, has put forth the need to leverage on the emerging science of cities and its tools and apply it to urban planning and governance to build a sustainable city fit for the future and its many challenges. It is thus important to embrace a culture of experimentation and be willing to test and fund new scientific approaches in making cities better for people. Innovative and sustainable solutions are critical for maintaining high livability and creating economic opportunities for citizens. Singapore has demonstrated that it has a system of governance and enablers for innovation to forge a living laboratory where companies and the research community partner government agencies to test and to commercialize new ideas for long-term sustainable development. For example, the HDB has worked with the Institute for High Performance Computing and the Institute for Infocom Research to develop the Integrated Environmental Modeling, which is a model platform that integrates the urban planning and design process with environmental simulation for town planning. The software platform uses 3D city models to simulate the interactions of urban microclimatic conditions, such as wind flow, natural ventilation, air temperature, solar irradiance, and noise levels, and their combined effects on the urban landscape. This reduces the risk of costly trial and error and allows development plans to be accurately simulated before actual implementation. The model was applied to Tengah New Town, where it enabled planners, architects, and engineers to analyze how various planning configurations will respond to prevailing environmental conditions. This has helped to optimize the building layouts and orientation to enhance wind flow, mitigate heat gain, and promote natural ventilation within the town. Tengah New Town will also be the testbed for scaling up many exciting, innovative urban solutions, including the pneumatic waste conveyance systems, district cooling system, and biophilic town planning. The HDB hopes to develop towns that are not only smart and biophilic, but will also enable more cohesive, resilient, and healthier communities within them. Residents would be able to take collective ownership of their living environment, enhanced by a strong sense of identity and belonging. And the HDB calls this the New Urban Kampung. The New Urban Kampung research program leveraged on technology and behavioral sciences to understand the diverse needs, aspirations, and lifestyles of the residents and how these might change over time. One of the tools developed is the agent-based virtual population model that forecasts population changes within a town, thus establishing its life cycle. With this dynamic agent-based virtual population model, it will be possible to visualize how town demographics will be impacted by major life event changes of individuals or households, like the arrival of a newborn or grown-up children moving out to set up their own families. By bringing together these urban analytics within a complex systems modeling platform, it allows the HDB to develop an understanding of the interdependencies between urban systems and social behavioral systems, which is then mapped out using a quality of life framework. This would allow the HDB planners to track the evolving needs of the town, formulate strategies, simulate their impact, and to ensure that their planning interventions and policies are well informed, responsive, and meaningful for residents. Planning for livable, dense, and green cities is especially important in the Singapore context, where it is increasingly common to co-locate community amenities and integrate skyrise greenery into buildings. A scientific and systematic analysis of the relationships between the inherent spatial networks of vertically integrated environments and how people use space in real life could help us understand how to plan better, for example, where to include mid-level community gardens and rooftop gardens to ensure that they are well used. The Vertical Cities project led by SUTD in collaboration with CLC, URA, and the HDB leveraged complexity science methodologies to understand the spatial networks and human movements at Kampong Admiralty. The project made use of a three-step methodology. First, the spatial network analysis examined the inherent network structure of Kampong Admiralty. Second, human mobility mapping was conducted with the use of people counters and Bluetooth beacon sensors to understand the emergent movement patterns and space usage. Third, a social spatial analysis was used to analyze the correlations between mobility patterns, occupancy time, and user types. Such a tool, when developed further, lays the foundation of developing a predictive modeling tool that can inform planning and design of future dense and green cities. Singapore is also embracing its city nature vision to chart out an even greener future. Scientific studies to integrate nature and greenery into increasingly urbanized environment helps to provide an evidence-based approach to realize such a vision. Our National Parks Board is already regarded internationally as taking a lead in scaling up a science of the city in nature. One example of innovation is the Remote Tree Measurement System, or RTMS. This system uses light detection and ranging, or LiDAR scans, and machine learning to remotely map the locations of individual trees and extract tree measurements. The data is then automatically uploaded into our National Tree Registry system, which allows NParks to efficiently construct an overview of the trees in the area. The RTMS will reduce the need for landscape workers to undertake laborious fieldwork to inspect trees and manually update tree records. Digital technologies and data-driven approaches have also improved the way parks are managed. For example, the Smart Gardens pilot initiative at Gardens by the Bay deploys digital technologies for plant monitoring and irrigation, lake management, lighting, and facilities management. Sensors provide analytics on soil and lake health while optimizing plant maintenance with the irrigation systems. Smart lighting technologies will enable preventive maintenance and energy savings. All these information will be managed by a cloud-based device management, control, and data acquisition system developed by the Sensors and IoT team at GovTech. Now for climate. Research had shown that from 1948 to 2016, the mean annual temperature rose at an average rate of 0.25 degrees Celsius per decade, and by 2100, the daily mean temperature is projected to increase by between 1.4 to 4.6 degrees Celsius. Computational techniques such as environmental and climate modeling have offered insights that guide the formulation of solutions to target hotspots. One such example is the Cooling Singapore project, a collaboration among great entities with SMU and NUS, which aims to mitigate the urban heat island effect, or UHI effects, by furthering the scientific knowledge required for better climate-sensitive design of the urban environment. The Cooling Singapore project developed an urban heat island, or UHI, intensity map of Singapore to analyze mitigation strategies. By adjusting the model inputs, planners will be able to observe how the UHI will be affected and study the best possible strategies to be implemented. Decision support tools for outdoor thermal comfort could also provide assessments of heat generating sources at district scale, as well as simulate the effect of heat mitigating strategies. It is exciting to hear that Cooling Singapore 2.0 will focus on developing an island-wide digital urban climate twin of Singapore by integrating various computational models with data on the environment, industry, building, and traffic, as well as regional and micro-scale climate models. Such a federation of models will help evaluate quantitatively various what-if scenarios for future UHI and outdoor thermal comfort analysis. For urban planning, the URA uses data analytics and geospatial technologies to gain deeper insights to make more informed decisions in planning for land use, amenities, and infrastructure. Through digitalization, planners can better process multiple data sets and plan in an integrative manner to meet Singapore's long-term planning needs. The ePlanner tool integrates over 100 data layers, such as land use mix, parking occupancy, accessibility to F&B spaces, etc., to complement groundwork and community engagement. The 3D Urban Planner is a 3D GIS platform developed by the URA that integrates diverse types of data, ranging from planning parameters for unique sites to detailed 3D planning information models in Singapore. By using such a platform, planners will be able to quickly visualize the requisite information to develop sensitive response strategies to the environment, for example, to safeguard important view corridors or the impact of shading of public spaces by buildings. Complexity scientists like Louis Bettencourt have acknowledged that challenges such as sustainability are complex and require adaptive and systemic approaches that yield emergent solutions. The world we inhabit has been called a VUCA world, a world confronted by volatility, uncertainty, complexity, and ambiguity, with interconnected challenges such as climate change, changing demographics, aging population, changing local and global economic structures, among others. The inherent unpredictability of a VUCA world makes planning for a sustainable future challenging due to the many possible alternate futures. One way to address this wicked problem is by backcasting, imagining our preferred future to identify what is needed to get there. However, it may no longer be enough to simply apply science and technology to domain-specific issues. Instead, understanding cities as economic entities or a collection of people, we will need to understand cities as a system of complex networks, interactions, relations, and flows at the global, regional, national, town, neighborhood, and individual scales. To deal with long-term sustainability challenges, we need to better understand the interdependency of energy resources and environmental, ecological, economic, social, and political systems to avoid unintentional consequences of particular policies or solutions. We need an integrated scientific framework, such as complexity science, to help us understand the relationship between human-engineered systems, both social and physical, and the natural environment to better plan and manage our cities. As pointed out by Louis Bettencourt in his article, The Uses of Big Data, it is important to understand the time scale at which urban challenges unfold and use big data to identify when to intervene and respond fast enough to avoid simple problems from becoming complex. He defines simple problems as those we can measure and are relatively easy to act upon. On the other hand, complex problems such as energy and sustainability are those that have impacts on other urban systems and scales and also involve multiple stakeholders. While data and technologies do not solve urban problems, they can enable planners to better understand how the city works and the timescale at which these challenges unfold and the key levers that could impact the urban landscape. This would help policymakers to know when and how to intervene to respond fast enough before more variables or complexities set in. Livability, sustainability, and resilience are pressing complex challenges. As we look ahead, we will need to tackle issues such as the trade-offs between urban greenery and built spaces, evolving social networks, resource circularity, climate change, etc. Problems that are all interconnected. We can no longer break down these challenges into small parts and tackle them in silos. A system of systems approach has to guide the scientific research on sustainable cities. In his article, The Uses of Big Data, Louis Bettencourt also shared on the planner's dilemma. The planner's dilemma has two aspects, the knowledge problem and the calculation problem. The knowledge problem refers to the information data that a planner would need to analyze to understand the current state of the city. However, the calculation problem is a more challenging one because regardless of how much data a planner might acquire, a city is computationally intractable, meaning it is impossible to accurately predict the city's trajectory due to the large amount of variables and self-organization within the city. Hence, adaptive planning for sustainability has to be supported by key enablers such as big data and the integration and coordination of people, firms, and organizations. Let us now touch on what are the potential enablers for a science of sustainable cities. Mr. Peter Ho, in his recent WCS keynote address, had shared on the need to probe, sense patterns, and to act, to experiment as a consortium of researchers, companies, government agencies, and communities. We are now in a better position to manage such complexities. The ubiquity of big data, coupled with high-performance computing, analytic tools to process unstructured data, and the rise of artificial intelligence allows for the analysis of a greater variety of data sets in novel combinations to discover new patterns and trends that better reflect reality and make accurate simulations. Better predictive management will allow city governments to act fast enough to prevent simple or predictable problems from becoming complex ones. The research community in Singapore has made good efforts to create data repositories and observatories. For example, SMU is developing the Social Urban Observatory, or SUO, which is a research platform that will gather large data sets and develop tools to generate insights on live, work, and play activities. More specifically, these data sets can be applied to use cases to study livability, sustainability, economic competitiveness, health and well-being, as well as social resilience. In an increasingly complex city, person-centric planning is important, where the various needs of different individuals would need to be connected by space, time, and budget, so that individuals with different needs could have sufficient resources to make choices to achieve a good quality of life. Scales and the interconnection between scales of the city, neighborhood, and individual are important considerations for person-centric planning. Big data is key in facilitating person-centric planning by enabling scientific analysis across scales and disciplines. Complexity scientist Jeffrey West observed that the future of humanity and the long-term sustainability of the planet are inextricably linked to the fate of cities. This is a compelling reason for us to develop a science of cities that can provide a framework for understanding how they work and what drives their growth and functioning. A key enabler is to take a practical approach of partnerships among researchers, companies, government agencies, and communities in pilots and experiments. It will be important to bring together various stakeholders, academics across different disciplines, politicians, policymakers, planners, engineers, administrators, and the community, not just to have dialogue, but to carry out pilots, demonstrations, and experiments to shape viable urban solutions. The science of sustainable cities is thus a collaborative project. Before I end off, I would like to share that the CLC will be organizing our 8th edition of the World City Summit from 31st July 2022 onwards. The World City Summit offers an effective platform for government leaders and industry experts to address livability and sustainable city challenges, share integrated urban solutions, and to forge new partnerships. We hope you will join us then. Thank you very much and stay in touch.
Thank you, Dr. Hee, for your very insightful talk. I believe we have one question from Hong Yuan. Hong, would you like to ask your question?
I think he's.
Okay.
It might have been an accidental raised hand. I saw it on. Well, okay. So while people are thinking about what they want to ask, so please, as a reminder, please either raise your hand or just type your question into the Q&A chat. While thinking about that, perhaps I will just start by first thanking Limin for that very comprehensive overview. I think your call to action at the end that this is a collective effort that the science of the community needs to work together to develop the science of sustainable cities. I think that's very timely because those on the call from the CREATE community would also recognize that we have an ongoing call for ideas, which is not just proposed ideas presented today, but still inviting ideas for what might be future programs in this space. So I think that overview you've given us gives us that fantastic sense of where some of the most interesting problem statements might be. I think Stefano wants to ask a question, but before I let him get on, but I want to just ask you to share your perspective from a CLC perspective. One of the challenges the scientific research community has in working in this space is that obviously we need to have a lot of conversations with the user stakeholder community, if you like, right? the public agencies. But as you were speaking, it occurred to me that CLC is in very much the same position. You are also trying to explain to the URAs and so on what they ought to be thinking about. At the same time, you're the interface to the research community. So do you have any guidance, comments on how we should conduct this conversation? This is something that, many researchers sort of say, we seem to be speaking a different language. So how do we bridge that divide?
Yes, Dr. Lim, thanks for that question. It's definitely very timely, and it is indeed. You point out very accurately that CLC does have a role to also try to be a bridge between experts and our agencies who are the one facing the challenges on the day-to-day level, and they have the excellent use cases for which research should be applied. But so it's we find it's often necessary to bring researchers and agencies who have the use cases together so that this, the great research minds that you have, for example, at CREATE, could be applied to real life challenges, where Singapore is very good at providing data, as well as, I think, the way our governance structure being one layer of governance makes it a lot easier for the kind of collaboration between researchers and agencies, more so, I would dare venture, than in many other places, because we do work with overseas scientists too, and they said they really envy how the setup in Singapore can allow this to happen in a much more immediate way. So I think we should harness this advantage that we have, and to bring together the research community with our agency use cases and our agency colleagues to work together. And CLC, of course, is very happy to play this convening role so that the conversations can be brought together as one conversation, instead of speaking many languages and not being able to understand each side of the that conversation. So so I will leave it at that. We have many platforms too, like big ones like the World City Summit and many of the workshops on research and various topics that we convene throughout the year. So we do hope that you would tune in to and watch this space. Thank you.
Okay, thanks, Dr. Lim. Dr. Hee, Prof. Costa Spanos also has a question.
Yes, thank you, Dr. Hee, for a very inspiring presentation. My question is quite general. I wonder if you can share some thoughts on your thinking on when you're facing problems of such complexity that evolve over decades, what kind of meaningful metrics can you set as a research program to judge your direction and success?
I think, as you said, the time scale of data is very important. So often, we need to look not at the problem, not as a snapshot, but to understand how the problem had developed over time, and also to have the data on a longitudinal basis to understand this better. And again, I bring in that what I said earlier, not just time, but also the correct scale at which research has to take place, or could have the most effective result in the first instance. So do we study this at what time scale and at what urban scale do we look at? So I think, because your question is quite general, so I apologize if my reply is quite general, but this has been an ongoing discussion, say, on topics like circularity, circular economy, and what is the best scale to study this problem. And I think that time dimension is also a very important one to bring in.
Thank you.
I think we can take one last question from the Q&A box. It's from someone who's anonymous. Sorry, Toby, yours just came in and I said it was the last one. So the first question was, most of the scientific research uses a reductionist approach to address and solve specific problems by breaking them into parts. Your talk discussed a lot about using complex systems approach to develop a science of cities. How can a reductionist approach be married with complex systems approach in this endeavor?
Thank you, Michelle, for reading that out. So yes, so I think what I'm trying to say is many scientific approaches are necessarily reductionist, so that a problem can, you can deep dive into how to solve it. But what complexity science advocates is to be able to harness various of these techniques together in a more holistic manner. So there are many ways of doing this. Like, for example, the project I shared, where in Kampong Admiralty, network analysis is actually coupled with actual sensors that are on people so that you could study how people move. But at the same time, it helps very much when you're able to carry out a social survey and analysis so that these data sets and findings could be put together to give you a holistic picture of what is going on, so that the solutions that we come up with do not have unintended consequences because we were looking at only one part of the elephant and not seeing the whole animal. So that's a very brief answer to actually a very difficult question. Thank you.
Thank you, Dr. Hee. I think we need to move on to our presentations.